Hello and welcome back to Engineers Olympiad. We are doing the weight volume relationships. This is the chapter that we are doing, and we are doing the numerical questions for the same chapter. In the previous video lectures, we have completed the multiple choice questions of the same chapter, weight volume relationships, from the subject Geotechnical Engineering. And this video lecture is about the numerical questions from the same topic, that is weight volume relationships in soil mass. All right, so let's get started. First question is, the mass of a chunk of moist soil is 20 kilograms and its volume is 0.011 cubic meter. After drying in oven, the mass reduces to 16.5 kgs. We have to determine the water content, the density of moist soil, the dry density, void ratio, porosity, and degree of saturation. All right, so let's get started. We have to see what data is given and what question actually demands from us. All right, so we have to determine the water content first. All right, and it's given that the mass of a chunk of moist soil is 20 kilograms. Mass of moist soil, how much is it? 20 kilograms as given in the question, and its volume is this much. After drying in oven, the mass reduces to 16.5 kgs. Dry soil, after drying in oven, the mass reduces to 16.5 kgs. Oven drying method is a very accurate laboratory method by which we can determine the water content in a given sample of a soil mass. All right, and as you already know that in oven we take this sample, we go on drying it for a period of about 24 hours, which is for most of the soils, and at a temperature of 110 degree plus minus 5 degree centigrade. That's also for most of the soils, unlike some of the soils which contain gypsum and most of the organic content. Their temperature range is not this. There it can go in the range between 60 to 80 degree, why we have already discussed in the previous video lectures, and the drying period can be even more than 24 hours. All right, so let's get back to the question. Now we have to see what is the mass of water. The mass of a chunk of moist soil was taken, and then the oven drying method was used to determine its water content. And how we can determine its water content? Mass of water will be 20 minus 16.5. All right, because mass of the moist soil is 20 kilograms. After drying it in oven for 24 hours, its mass of the dry soil is 16.5 kilograms. So mass of the water will be 20 minus 16.5 kilograms. That is about 3.5 kgs. All right, and now since we know the mass of water, we can calculate the water content in this soil. Water content, denoted by W, is the ratio between mass of water divided by mass of soil solids. All right, so water content is mass of water, how much? 3.5 kilograms, and mass of soil solids is how much? 16.5, because after oven drying its mass reduced from 20 kgs to 16.5 kgs. So water content by calculations is equal to 21.21%. All right, so 21.21% is the water content in this mass of a chunk of soil that was placed in oven, and then it was oven dried accordingly. All right, so this is about the first part of the question, that we have found the water content. Now the next thing that we need to find out is the density of moist soil. All right, density of moist soil, that means the bulk density. Bulk density, or the density of the moist soil, denoted by this. This is mass per unit volume. How much is the mass of moist soil? It was 20 kilograms before oven drying. So mass is 20. How much is the volume? It's already given in the question. The mass of a chunk of moist soil is 20 kgs and its volume is 0.011 cubic meter. All right, 0.011. So by calculations, bulk density or moist density is 1818.18 kilograms per cubic meter. So part second is also completed. We have found the water content. We have already discussed about the water content and the oven drying method and all. Secondly, we have also found the density of the moist soil or the bulk density, and that is equal to this much. All right. What question demands next? The dry density. That's what we have to find now. Dry density. Dry density. Dry density denoted by this is mass of soil solids divided by total volume. Soil solids, how much? 16.5, because when this mass of chunk of moist soil was placed in oven, its total mass at that particular period of time was 20 kgs. After drying in oven, all the water content was gone. The remaining mass was 16.5 kilograms. That is the mass of the dry soil, and that we can say that it is the mass of the soil solids, because the water got completely evaporated. So we're left with mass of the soil solids, that is 16.5 kgs, and the volume, it is same, 0.011. By calculations, it is equal to 1500 kg per cubic meter. So this is the dry density of the soil sample which was placed in oven and was oven dried. All right, what question demands next? Question says find the void ratio, and then we have to subsequently find the porosity and degree of saturation as well. First, void ratio. Okay, for void ratio, we know the correct relation or the expression that we are going to use is that dry density is equal to this. All right, so this is the general expression. We know this, we know this, we know this. It's given in the question. We have to find the void ratio. All right, so let's go on substituting the values and find the void ratio. All right, dry density, how much? 1500. Or let me write it first, the expression, to make it a little convenient. All right, so I may write it 1 plus E is G rho W divided by dry density. All right, or I may write it 1 E is equal to G rho W divided by dry density minus 1. All right, so E is equal to G, specific gravity given in question. Take G 2.70. 2.70. This is the density of water, which is 1000 kilograms per cubic meter. Dry density, we have just, all right, calculated it. It's 1500 minus 1. This was dry density of soil, which we just found out. It was 1500 kgs per cubic meter, and this is the density of water, whose value is 1000 kilograms per cubic meter. We have substituted these values in this expression, and we are subsequently going to find out the void ratio of this particular soil mass. All right, so the void ratio is, by calculation, since we have substituted the values by calculation, so void ratio is 0.80. All right, so we have found the void ratio as well. Next thing that we need to find out is this porosity, right? And we also know the expression relating void ratio and porosity. We have also learned about it before. All right, so let me rub it first, or let me write it here. We know that porosity, or the percentage voids, it is equal to, it is denoted by N, and it is related to void ratio by this equation or by this expression. So we will substitute the values and find the value for porosity. E, we have just find out 0.80. So it's 1 plus 0.80. By calculations, porosity is 44.44%, because we usually express it as percentage, but in computations we take it as a decimal. All right, so we have found the porosity as well, and it is equal to 44.44%. The last thing that we need to find out in this question is degree of saturation. All right, and the expression, let me rub it first. All right, thing is degree of saturation. Degree of saturation is related to the other parameters that we have already found before in this question by this expression. We know the general expression is ES is equal to WG, where E is the void ratio, S is the degree of saturation, W is the water content, and G is the specific gravity of the soil solid particles. All right, so we'll go on substituting the values and finding the degree of saturation accordingly. All right, W, water content, we just found out 21.21%. Here we'll use it as a decimal, so it's 0.2121. Specific gravity given in the question 2.70. Void ratio we just found out 0.80. By calculations, my degree of saturation is 71.58%. All right, my degree of saturation is 71.58%. So we completely solved this question. We found out the water content, the density of moist soil, or the bulk density. We found out the dry density, void ratio, porosity, and the degree of saturation as well. All right, so let's move to another question. All right, question is, a soil specimen has a water content of 10% and a wet unit weight of 20 kilonewton per cubic meter. If the specific gravity of solids is 2.70, determine the dry unit weight, void ratio, and the degree of saturation. All right, take unit weight of water as 10 kilonewton per cubic meter. All right, so let's solve this question. What do we need to find first? We have to find the dry unit weight, the void ratio, and the degree of saturation. All right, and what is given in the question? A soil specimen has a water content of 10%. All right, and a wet unit weight of 20 kilonewton per cubic meter. Wet unit weight means the bulk unit weight. All right, or the moist unit weight or the bulk unit weight, that is given to be 20 kilonewton per cubic meter. All right, and the first thing that we need to find out is the dry unit weight. All right, we know the expression relating dry unit weight and the bulk unit weight and the water content, and that is dry unit weight is equal to bulk unit weight 1 plus W. All right, where this is the dry unit weight, this is the bulk or the moist unit weight, and this is the water content in the soil specimen. All right, and let us substitute the values and go on finding the first thing, that is the dry unit weight. Bulk unit weight, how much? 20. 1 plus water content, that is 10%. We have to use it as a decimal in computation. So by calculations, my dry unit weight is equal to 18.18 kilonewton per cubic meter. All right, this is the first thing that we have found out, and this is what question was demanding, that determine the dry unit weight. We have found it out. It is 18.18 kilonewton per cubic meter, the dry unit weight. Next thing that we need to find is the void ratio, and then lastly we have to find the degree of saturation. With the given data, we know the expression that we'll use is dry unit weight is G 1 plus C. This is the expression relating these terms: the dry unit weight, the unit weight of water, void ratio, and the specific gravity of soil solids. All right, this is the expression. We know the values. We'll go on finding the void ratio from the same expression. All right, so let me write it like this first. 1 plus E is equal to G. All right, or E is equal to minus 1. All right. So void ratio is G. G. If the specific gravity of solids is 2.70. 2.70. This is the unit weight of water, and we have been asked to take it as 10 kilonewton per cubic meter. So 10 kilonewton per cubic meter divided by the dry unit weight, which we found out just before finding the void ratio. It's 18.18. 18.18 minus 1. All right. So by calculations, E is equal to 0.48. All right. So this is the value of the void ratio. Then we have to find the degree of saturation, and that's the last thing that question demands us. We have found the dry unit weight, void ratio, and the degree of saturation. We know the expression relating these parameters is ES is equal to WG. That means S is equal to WG divided by E. We have water content as how much? 10%. So it is 0.10. Specific gravity is 2.70. Void ratio we just found 0.48. By calculations, degree of saturation is 56.25%. All right. So we have completed all the things. We have found the dry unit weight, the void ratio, and the degree of saturation as well. All right. So this was about the question. Moving on to the next one. All right. Question is, a sample of dry soil weighs 68 grams. Find the volume of voids if the total volume of the sample is 40 milliliters and the specific gravity of solids is 2.65. Also determine the void ratio. All right. So this is the question. All right. So coming back to the question, a sample of dry soil weighs 68 grams. Find the volume of voids if the total volume of the sample is 40 milliliters and the specific gravity of solids is 2.65. Also determine the void ratio. Let's go on solving this question. All right. So the first thing that we'll find is the dry density. All right. How much? A sample of dry soil weighs 68 grams. Find the volume of voids if the total volume of the sample is 40 milliliters. All right. So we have been given the data that is being given is weight or the mass, that is 68 grams, and the volume, total volume, that is 40 milliliters. A sample of dry soil weighs, that means we'll find this will be the mass of the soil solids because it is given in the question a sample of dry soil weighs. All right. So we'll go on finding the dry density. It is mass of soil solids divided by total volume. We'll substitute the values 68 here 40. By calculations, it is 1.7 grams per milliliter. This is the dry density of the soil. All right. What question demands? Question asks us a sample, find the volume of voids if the total volume is this. We have to find the volume of voids. All right. If the total volume is this much. All right. All right. So we found the dry density, which is 1.7 grams per liter from the expression relating dry density and specific gravity and the density of water. We can find the void ratio as well. All right. We can find it by number of ways, rather, but the expression which we are going to use here is this one. All right. So let's go on substituting the values and finding the void ratio. All right. This will become this, and then void ratio is all right, minus 1. So void ratio here will be how much? G. Specific gravity, we have been asked that the specific gravity of soil solids to be taken is 2.65. So it's 2.65. Density of water is 1 gram per milliliter. It is 1 grams per milliliter or 1000 kgs per cubic meter. All right. Since other terms here are in this unit, gram per milliliter, so we'll use the accordingly. All right. Dry density, how much? We just found out 1.7 grams per milliliter. So it's 1.7 over here. All right. So by calculations, void ratio is equal to, it is equal to 0.55. All right. Void ratio is equal to 0.55. So we found the dry density, we found the void ratio. Now we have to also find one more thing. Find the volume of voids if the total volume is this. We have to find the volume of voids. And for that, we'll use this expression first. Specific gravity is mass of soil solids divided by volume of solids multiplied by the density of the water. All right. It is given over here. We'll use this. All right. So specific gravity, that thing is given over here. How much is the value? It is 2.65. Or let me write this. Volume of soil solids is ms by g, or volume of solids is equal to mass of soil solids divided by, all right. So this is the expression relating these terms. We will go on substituting the values and finding the answer, because we have to find the volume of the voids. For that, we must know, since we know the total volume, we have to find the volume of voids, but for that we must know the volume of solids first. All right. So that's why we are using this expression and trying to find the volume of solids first, so that we can find the volume of voids, because total volume is given and the volume of voids need to be found out. All right. So let's substitute the values. Volume of solids is mass. Mass is 68 grams. A sample of dry soil weighs 68 grams. That means this is the mass of the soil solids. How much? 68 grams. Specific gravity is 2.65. And this thing over here is 1 gram per milliliter. All right. All right. So by calculations, it is equal to 25.66 milliliters. All right. By calculations, we have found out the volume of solids. It is equal to 25.66 milliliters, or we may also say cubic centimeters. All right. So it is 25.66 milliliters, so 25.66 cubic centimeters. All right. So now the thing that needs to be found out is the volume of the voids, because that's what the question demands. It asks us to determine the volume of voids when the total volume is given. Volume of soil solids we have found out. We can now use the expression and go on finding the volume of the voids. How? Volume of voids, or first I write total volume is volume of soil solids plus volume of voids. All right. So volume of voids is total volume minus volume of solids volume of whites will be total volume. How much? 40 milliliters. It is 40 milliliters. That is the total volume minus volume of soil solids that we have found 25.66 milliliters. So volume of whites will be 14.34 milliliters. All right. So this was about this question. The question was, a sample of dry soil weighs 68 grams. Find the volume of whites if the total volume of the sample is 40 milliliters and the specific gravity of solids was given. Also determine the white ratio. There are a number of ways by which we can solve this question, but this is how we solved. We found the dry density first, then we used the expression connecting dry density and white ratio, and we found the white ratio as well. Then we used the expression by which we can find the volume of soil solids, and we use the expression between specific gravity, mass of soil solids, and the unit weight of water. Luckily we had this term because the question in itself was saying that the sample of dry soil weighs 68 grams. So we had this thing. Then we found out the volume of soil solids. We had the total volume. We found this, so we determined the volume of the whites, which came out to be 14.34 milliliters. All right, moving on to the next one. Question is a moist soil sample. We have to be very careful with what question asks us. Sometimes it gives us the densities of moist soil. Sometimes it relates with the dry densities, and it says that the sample of dry soil weighs this much. So we have to be very careful about these things. Rest we can very easily proceed with expressions. All right. Coming back to the question is, a moist soil sample weighs 3.52 Newton. After drying in the oven, its weight is reduced to 2.9 Newton. The specific gravity of solids and the mass specific gravity are respectively this and this. We have to determine the water content, white ratio, porosity, and the degree of saturation. We have to take unit weight of water as 10 kilonewton per cubic meter. All right. So let's go on solving this question. What data has been provided? A moist soil sample weighs 3.52 Newton. Weight of moist soil, how much? 3.52 Newton. Then it says after drying in the oven, its weight was reduced to 2.9 Newtons. Weight of dry soil, 2.9 Newtons. We can find the weight of water. It will be weight of moist soil minus weight of the dry soil. So weight of water, how much? 3.52 Newton minus 2.9 Newton, which is 0.62 Newton. This is the weight of water. All right. We have to determine the water content. All right. We have to determine the water content, the white ratio, the porosity, and the degree of saturation. All right. Water content we'll find first. Water content. It is equal to weight of water all right, divided by weight of the dry soil. This will be how much? Weight of water is 0.62. Dry soil is 2.90. So the water content is equal to, by calculations, it is equal to 21.38%. This is the water content in this soil sample. It is how much? It is 21.38%. All right. Next, what question asks us? Determine the water content, the white ratio. All right, so we have to determine the void ratio. For that, we must be knowing the dry unit weight first. All right, for finding out the void ratio, we must be having the dry unit weight first. So let's do that first. All right, dry unit weight is equal to bulk unit weight divided by 1 plus water content. But for that, we must be knowing this thing, that is bulk unit weight, and that is where this thing will come handy. Mass specific gravity has been given. Mass specific gravity has been given. By that thing will arrive at the bulk unit weight. How so? Because mass specific gravity it is denoted by Gm. It is equal to bulk unit weight divided by the unit weight of water. It is given. How much is it? Mass specific gravity is 1.85. So 1.85 is bulk unit weight divided by weight of water. That is given in the question. We have to use it as 10 kilonewton per cubic meter. So by expressions, bulk unit weight is 18.5. By calculations, bulk unit weight is 18.5 kilonewton per cubic meter. Alright, so when we know this, we'll arrive at this thing and then subsequently add void ratio, porosity, degree of saturation, etc. And what came handy over here was this thing, the mass specific gravity, which was given, and it's the ratio between bulk unit weight to the unit weight of the water, or the bulk density to the density of the water. All right, so let's use this expression and let's find the dry unit weight first. Dry unit weight is equal to bulk unit weight divided by 1 plus water content. So bulk unit weight is 18.5, 1 plus water content we found 21.38%. So it's 0.2138 because we use it as decimal in computation and report it as percentages. So dry unit weight by calculations is 15.24 kilonewton per cubic meter. Now, when we found the dry unit weight by expressions relating specific gravity and the unit weight of water, we'll go on finding the void ratio because the expression is dry unit weight is G rho W 1 plus E. All right. So this is the expression. And let's find out the void ratio. E is equal to G minus 1. E is G specific gravity given in the question to be taken as 2.65. 2.65 weight of water 10 kilonewton per cubic meter. That is what we have to take. The dry unit weight we just found out 15.24 minus 1. All right, this is 15.24. By calculations, void ratio is equal to 0.74. All right, by calculations the void ratio is equal to 0.74. After that, we have to find the porosity and the degree of saturation. That's what the question demands. Yeah, determine the water content. That we have already calculated. Void ratio we just found out 0.74. The only two things that are remaining are these, porosity and the degree of saturation. We'll find them as well because we know the expression relating porosity and the void ratio is this. We know the void ratio, we can find the porosity. It is 42.52%. All right, the last thing that we need to find out is the degree of saturation, and we know degree of saturation is this. We'll substitute the values and we'll find the answer. Water content 21.38%, specific gravity 2.65, void ratio 0.74. So by calculations, degree of saturation is 76.56%. All right, so that's how we have calculated all the things, whatever question demanded. We have determined the water content, the white ratio, the porosity, and the degree of saturation. All right. So this was about this question. Moving on to the next one. All right. Question is, a soil has a porosity of 40%. The specific gravity of solids is 2.65 and a water content of 12%. Determine the mass of water required to be added to 100 cubic meter of this soil for full saturation. All right. So this is the question. A soil has a porosity of 40%. The specific gravity of solids is 2.65 and a water content of 12%. Determine the mass of water required to be added to 100 cubic meters of this soil for full saturation. All right, so let's get started and let's solve this question. All right. Data that has been given is porosity 40% or let's say 0.40. Specific gravity 2.65. Water content 0.12. Right? So determine the mass of water required to be added to 100 cubic meters of the soil so that the soil will be fully saturated. All right. Let's go on finding the degree of saturation first, because we have to determine the mass of water required to be added to the 100 cubic meter of this soil for full saturation. We have to see what is the degree of saturation currently. Degree of saturation S Wg divided by E. Water content 0.12, specific gravity 2.65, and E 0.66. All right, E. We don't know E, we know N, but we know the expression relating porosity and the white ratio. E is equal to N divided by 1 minus N. E, white ratio, porosity 0.40 divided by 1 minus 0.40. By calculations, white ratio is equal to 0.66. We use the expression relating porosity and the white ratio, and we found out the white ratio because porosity was given, and we found out the white ratio. All right, so we will use it here in the expression 0.66, and by calculations or computations, the value of degree of saturation, it comes out 48.18%. All right, so this is the degree of the saturation of the soil sample. Currently it is 48.18%. Now the thing that we need to find is the mass of water required to be added to this much of the soil so that it will achieve full saturation. For that, we have to know the things: the volume of voids, the volume of water, the volume of soil solids in the soil sample. All right, then only we can find the mass of water that is required to achieve full saturation. All right. We know N is equal to volume of voids divided by total volume. This is the porosity. It is equal to volume of voids divided by the total volume. That means volume of voids is equal to porosity multiplied by the total volume. All right. Volume of voids will be porosity, that is given 0.40, multiplied by the total volume. Total volume is mass of water required to be added to this much, because we have to calculate everything at this particular volume, because we have to determine the mass of the water that is to be added to this particular volume of the soil so that it will achieve full saturation. So the volume is 100 cubic meters. So volume of voids is 40 cubic meter. All right. Since we know that the porosity is a ratio between volume of voids to the total volume, we use the expression and we found out the volume of voids because total volume and the porosity was given. So the volume of voids 40 cubic meter. Current volume is because we know degree of saturation is volume of water divided by volume of voids. All right, current volume of water, we'll find it out by the degree of saturation. That's why we found the degree of saturation first, and we'll use the expression because degree of saturation is also a ratio. Degree of saturation is also a ratio between volume of water to the volume of the voids. So volume of water is, all right, volume of water, degree of saturation, we calculated how much? It was 48.18%. So 0.4818. Volume of voids, we just found out 40 cubic meter. That is how we'll arrive at this thing, volume of water. By calculations, it is 19.27 cubic meter. All right. So the volume of the water is 19.27 cubic meter. Now the additional water required for full saturation. At full saturation, at full saturation, at full saturation, volume of water is how much? Volume of voids. Because at full saturation, there is no air phase, soil becomes a two-phase system from its regular three-phase system. It is reduced to the mass of the solids, and the voids are filled with only water because there is no air phase when the soil is at its full saturation. So the volume of water in the voids is equal to the total volume of the voids, because in voids there is no air phase, only water. So at full saturation, these two parameters equate themselves. All right, volume of water becomes equal to the volume of voids, and we know the volume of voids is how much? 40. So at full saturation, volume of water will be 40 cubic meter. So additional water required, it itself says, the question itself demands, determine the mass of water required to be added to this much of soil so that it will be fully saturated. So the additional water required to be added to 100 cubic meter of this soil for full saturation is how much? Currently it has this much. For full saturation it should be having this much, so it will be additional water required to be W additional is 40 minus 19.2527, which by calculations is 20.73 cubic meter. So this is the total volume of the water we need to add to this 100 cubic meter of this soil so that it will be fully saturated. All the voids will be filled with only water and there will be no air phase at all. Soil will be completely reduced to a two-phase system. So we have found the volume, all right, but the question demands determine the mass of the water to be required, all right. So the mass of the water added is, we'll go on multiplying by density to find the mass. Mass of water, additional water to be added is how much? Mass is volume multiplied by the density of the water, which is 1000 kilograms per cubic meter. So mass of the water added is 20730 kgs. So this is the additional mass of the water and this is the additional volume of the water that needs to be added to 100 cubic meter of this soil having these details so that it will be fully saturated. All right, so this is how we proceeded with the question. We found out the degree of saturation first. We found out the void ratio from the porosity given. Then we found out the volume of the voids from the porosity, because porosity is a ratio between volume of voids to the total volume. We found the volume of the voids. We found the current volume of the water from the degree of saturation that we calculated first, because we know that the degree of saturation is also a ratio between volume of water to the volume of the voids. We found out the volume of the water, all right, and then currently, all right, then at full saturation, when there will be no air phase, all the voids will be filled with only water. At that time, volume of voids will equate to the volume of water, because at full saturation there will be completely no air phase, all the voids will be filled completely with the water. We knew the total voids, total volume of voids from the porosity thing. Then these two will be equal at this condition at full saturation, so it will be 40 cubic meters, but the current volume of the water came out only to 19.27 cubic meters. So the additional water required was how much? Additional water required to 100 cubic meter of this soil came out to be 20.73 cubic meters, but the question was asking us to determine, to report the answer in terms of mass. So we multiplied by the density of the water, which is 1000 kilograms per cubic meter, and the mass of the water to be added to 100 cubic meter of this soil, so that it will arrive at its full saturation stage, came out to be 20730 kilograms. All right, moving on to the next one. Question is, a sample of saturated soil has a water content of 25%. All right, a sample of saturated soil has a water content of 25% and a bulk unit weight of 20 kilonewton per cubic meter. Determine the dry density, the void ratio, the specific gravity. What would be the bulk unit weight of the same soil at the same void ratio but at a degree of saturation of 80%? We have to take the unit weight of the water as 10 kilonewton per cubic meter. All right, so let's solve this. The first thing that question demands is determine the dry density. All right, we know the bulk unit weight, we have the water content, we can very easily find the dry density. All right, so it is bulk divided by 1 plus water content. This will be bulk unit weight is how much? It is 20 kilonewton per cubic meter. 20 kilonewton per cubic meter. 1 plus water content is how much? Water content is 25%, so it's 0.25. By calculations, the dry unit weight is 16.0 kilonewton per cubic meter. All right, because we had the bulk unit weight, we had the water content, we very easily found out the dry unit weight, which came out to be 16.0 kilonewton per cubic meter. All right, next thing is void ratio and the specific gravity needs to be found out. All right, see how we'll proceed with this question. We know this expression ES is equal to WG. All right, we know degree of saturation, or S, is 1. Why? Because question itself says a sample of saturated soil, so S is 1. So if I'll substitute it here, E is equal to W, 25%, G. So E is equal to 0.25 G. This is expression, let me name it A. All right, next condition that we know for saturated soils, this is equal to G plus E 1 plus E. This is for fully saturated soils. So let's derive second expression so that we can find this and this. That's what the question demands, to find the void ratio and the specific gravity. So we are using the terms or the expressions for the fully saturated soil conditions, and then we'll arrive at these two parameters, the void ratio and the specific gravity. We're making use of the condition that the soil is fully saturated. All right, here it is G plus E unit weight is 10 divided by 1 plus E. Saturated, it is how much? 20. All right. It is 20. It is given. A sample of a saturated soil has a water content of 25% and a bulk unit weight of 20 kilonewton per cubic meter, because in this condition, this bulk unit weight is the saturated unit weight, all right, because the soil is fully saturated. So this is 20 G plus E, 10 1 plus E. All right, I may write G plus E divided by 1 plus E is equal to how much? 2, or G plus E is equal to twice plus 2E, or G is equal to, this will become 2 plus E. All right, so G is equal to 2 plus, let's make the use of equation or the expression A. E is equal to 0.25 G. So we'll substitute the value here. E is equal to 0.25 G, or G minus 0.25 G is equal to 2, or 0.75 G is equal to 2. That means G will become 2.66. So if G is 2.66, from expression A, E is equal to 0.25 into 2.66. That means E will be 0.665. All right. Or in the expressions, we'll use it as 0.66, let's suppose. This is how we made the use of the condition that the soil was fully saturated, and we arrived at these two parameters, the void ratio, which came out to be 0.66, and the specific gravity, which is 2.66. All right, what next? All right, determine the dry density. We have found out void ratio, done, and the specific gravity of soil solids. Nice, we have done it again. The last thing that needs to find is what would be the bulk unit weight of the same soil at the same void ratio but at a degree of saturation of 80%. All right, we know the general expression. Rating bulk unit weight is G plus SE, unit weight of water, divided by 1 plus E. Question asks us to find the bulk unit weight of the same soil at the same void ratio but at a degree of saturation of 80%, not at 100%. All right, so let's find out. We have to find this. We know G is how much? G is 2.66. Degree of saturation, 80% saturation, 0.80. Void ratio, 0.66. Unit weight of water, 10 kilonewton per cubic meter. That's what question says to use. Yeah, 10 kilonewton per cubic meter. 1 plus E. Void ratio is 0.66. All right. So this thing will become, by calculations, so bulk unit weight at 80% saturation but at the same void ratio is 19.20 kilonewton per cubic meter. All right, so this is how we arrived at each and every parameter that question demanded to find. All right, so the bulk unit weight is 19.20 kilonewton per cubic meter at 80% saturation but at the same void ratio of 0.66, which was at the full saturation. All right, moving on to the next one. All right, so the question is, A sample of clay was coated with paraffin wax and its mass, including the mass of wax, was found to be 697.5 grams. The sample was immersed in water and the volume of the water displaced was found to be 355 milliliters. The mass of the sample without wax was this, and the water content of the representative sample specimen was 18%. Determine the bulk density, dry density, void ratio, degree of saturation. The specific gravity of solids was this, and the specific gravity of the wax was 0.89. If you analyze this question, this is about the water displacement method which we use in geotechnical engineering to go on finding certain properties of the soils, such as the bulk density, dry density, and the unit weights, etc. All right. So let's get back to the question and let's solve it. All right. We know the mass, a sample of clay which was coated with paraffin wax so that it may not disintegrate in water. That's why we coated with wax before using the water displacement method. Alright, including that of the mass of the wax was found out to 697.5 grams. So this is mass of soil coated with paraffin wax. How much? 697.5 grams. Alright. The mass of the sample without wax was 690 grams. Mass of soil without coating, without wax is how much? 690 grams. That means mass of the wax itself is how much? Mass of wax is 697.5 minus 690. 697.50 minus 690, that is 7.5 grams, is the mass of the coating or the paraffin wax that we have used to coat this mass of the soil sample so that it may not disintegrate while we are using the water displacement method for finding out the certain parameters. All right. So this is the mass of the wax. Volume displaced. Volume displaced is how much? Clay plus wax both. Volume. It's here. The sample was immersed in water and the volume of the water displaced was found out to be 355 milliliters. So this was a sample with coating, because if we'll use without coating, it will disintegrate in water. So this is the volume displaced by both clay plus wax. It is 355 milliliters. All right, 355 milliliters. After that, specific gravity of wax is equal to, we'll make use of this expression, volume of wax, density of water. All right, this is given. Specific gravity of wax is given 0.89. So 0.89 mass of wax we just found out in the very beginning, 7.5 grams. This thing we are interested in to find volume of wax, density of water. It is 1 gram per milliliter. So by calculations, volume of wax, it comes out to be 8.42 milliliters. That means volume of soil specimen is how much? All right, total volume minus volume of wax. Total volume is how much? 355 milliliters. Volume of volume of wax 8.42 milliliters, by calculations 346.58 milliliters. All right, so this is the volume of the soil specimen. Let's go on finding the parameters first. Determine the bulk density, dry density, white ratio, degree of saturation. First, bulk density. Bulk density, all right, bulk density is how much? Mass per unit volume, mass of soil specimen without wax, 690. That is very important. Don't ever use with wax. That won't give us the correct representative factors. Volume of the soil specimen 346.58. 346.58. Bulk density 1.99 grams per milliliter. After that, we'll find the dry density. We know the expression dry density is equal to bulk density divided by 1 plus water content. So dry density is bulk density 1.99 divided by 1 plus water content. It's already given in the question itself. The water content of the representative sample was found out before testing it in the water displacement method. It was tested and it was found out to be 18%. 0.18. By calculations, the dry density is 1.686 grams per milliliter. What else do we need to find? Bulk density is done, dry density is done. We need to find the void ratio and the degree of saturation. For void ratio, we'll make use of the expression, this one. I don't have space here. Let me know with something. Right? For finding out the void ratio, we know the expression relating dry density and the void ratio, G rho W1 plus E. Dry density, we found out it was 1.686 grams per milliliter. Specific gravity of the soil, not of the wax. How much? 2.70. The specific gravity of the solids, 2.70. So 2.70 is here. Density of the water is 1 gram per milliliter. 1 plus E. By calculation, E is equal to 0.60. 0.60. We found the void ratio. We can easily find the degree of saturation. S is equal to Wg divided by E. Alright, S is equal to Wg divided by E. So S is water content is 0.18. Specific gravity is 2.7. Void ratio is 0.60. By calculations, degree of saturation is 81%. Alright. So the degree of saturation is 81%. So this was about the water displacement method by which we go on finding certain parameters like the bulk density, the dry density, the void ratios, and subsequently the degree of saturation, etc. But the factor or the point which we must be knowing beforehand is the water content of that soil sample. All right. And we make use of some coating agent. Here we use paraffin wax so that while immersing it in the water, in this water displacement method, it won't disintegrate. All right. So that's how it works out.